Coming up on This Week in Radio Tech, what do you do when your translator site is paying 95 cents a kilowatt hour for electricity? And maybe it's not even available at all. Well, you use wind and solar power, and that's what Becky and Pete of KCAW in Sitka, Alaska, are here to talk about. We're going to find out about wind power, solar power, and how they can make the most out of all the different sources of power that they have. Just a little bit of each. Coming up next on TWiRT. This Week in Radio Tech is brought to you by Broadcasters General Store, with outstanding service, savings, and support. Online at bgs.cc. By Broadcast Bionics, with the Bionics Studio, including talk show control, social media, and visual radio. Broadcast Bionics brings exceptional audience engagement to radio and TV. By Angry Audio. Audio problems disappear when you get angry at angryaudio.com. By Nautel, worry-free transmission you can count on with outstanding control, reliability, efficiencies, and Nautel's unmatched 24/7 customer support. Online at nautel.com. And by Max Connect Wireless, prioritized high-speed internet service designed for transmitter sites and remote broadcasts. Hey, welcome into This Week in Radio Tech, the show where we talk about everything from the microphone to the light bulb at the top of the tower. I'm Kirk Harnack here in the Nashville, Tennessee studio of This Week in Radio Tech. It's the Telos Alliance studio, as you can see by the sign on the wall there. Telos is my employer, and they kindly give me an hour and a half off on Thursday afternoons to meet with you and to talk with interesting people in the radio business. We try to talk about technology, and we've got a very interesting show today that I'm looking forward to because I'm going to put this information to use myself. So here in Nashville, Tennessee, it's a late summer day. The temperatures are cooling off, and joining us today from Mukwonago, Wisconsin, is Chris Tarr. Hey, Chris, good to see you.
Hello there. I'm from the other TWiRT studio. This is the Louie Dog Punch studio. Louie's my dog. We call him Louie Dog Punch. That's where we're live from today. Let me open up MukwonagoWeather.com, and I can tell you exactly what it is. 73 and cloudy here in Mukwonago today. Been kind of rainy, so I'm actually glad to be in the house. But anyway, good to be here. I missed a couple of weeks, I think, so it's good to be back in the co-host chair.
Yeah, it's good. It's good to see you. Well, Chris, I'm glad you could join us because for a while you worked outside of the usual corporate radio grind. You worked in community radio, maybe a different kind of grind. And we have some community radio people on with us today. In fact, Chris, the topic for today is alternative or renewable power sources for powering sometimes some pretty remote transmission facilities. So let me introduce to you Becky Meiers and Pete Tridish. Becky and Pete, welcome in. Understand you are coming to us from the Western office in Alaska. Hi, good to see you.
Hi, thanks for having us.
Great to be here.
You're in Sitka, Alaska. I've been to Sitka just long enough for the plane to land and turn around and take off.
Oh, yeah. Well, right now it is 50s, raining, and we're really glad to be inside, too. It'll probably get like 4 inches of rain today here.
Becky is the operations director at KCAW, and Pete is the director of electromagnetism with the International Media Action. And Pete has an article that he's written in Radio World. We're going to take a look at some pictures and diagrams from that article. And Becky and Pete, before we really jump in the deep stuff here, kind of give us a little preview. What are we going to be talking about? Why did I ask you to be on this show?
Well, we're going to be talking about our upgrade project for our translators. KCAW has 7 translators that are all throughout Southeast Alaska that cover a range of about 300 miles, roughly the same distance from DC to what?
New York.
New York.
Wow.
And nothing is connected by roads. You can only get around by plane or boat. And we installed these translators back in the 80s. And so all of them, when I came to KCAW in 2019, I discovered that they hadn't been looked after at all, really. They were vastly underpowered and operating on some pretty decrepit equipment, while station priorities through that time were different. Once I got here, saw that there was a need for people, especially in those communities who don't have regular access to cell phones or internet, that they have a reliable FM service that serves them in good times as well as bad, with emergency alerting and catastrophic things that can happen in our communities. And so was looking to upgrade all the equipment. But we realized pretty quickly on in the design of the project that we would need to figure out what our part would be in providing power in order to upgrade the constant power that we use for broadcast. And so that's when Pete and I started working together in order to design systems that would be able to power the necessary equipment upgrades that we were planning, as well as be energy independent and resilient throughout the year.
Mm-hmm. Yeah, and for a little context, I actually studied solar before I became a broadcast engineer. And when we went to the first community that we worked in, Port Alexander, we discovered, at first Becky was talking with the people in the community about them continuing to provide power for the station and upgrading it to 250 watts. And very immediately there was a pretty hard no.
Yeah.
Because to most broadcasters, 250 watts doesn't sound like a lot of power, and to most Americans. But in towns like this, Port Alexander has no grid. The only power available is from generators that people have personally, or that belong to, there's one that runs the town. It keeps up a town battery bank. So we really, they count their watts in Port Alexander the way, people count their pennies. And to me, that makes a lot of sense, because, coming from a background and doing some off-grid solar back in the 90s, when you're really thinking about it, like the number of kilowatt hours you've got banked, just like you think about a bank account. So, and now Port Alexander is the only town that doesn't have any public utility whatsoever, but a lot of them, the cost per kilowatt hour, the average cost per kilowatt hour in the United States is about 13 cents a kilowatt hour. Mm-hmm. But in towns like Elfin Cove, it's 95 cents a kilowatt hour, because all there is a diesel engine. Mm-hmm. Some of the communities have some hydropower, but mostly it's quite expensive. Everything that gets to that town. Remember, this is an archipelago. It's a bunch of islands, and most of them don't have any cables or pipes or roads or anything like that connecting them.
Wow, Becky and Pete, this is a great setup for the show that's coming up. We're going to have pictures of the first installation, some graphs that, or some pictures that Pete has made as part of his article in Radio World sometime back, and Chris is going to be along here to add what he knows or learn, ask questions, so we all can learn from their experience. And myself, at some point, we're going to be putting a translator in the Manua Islands. It's part of American Samoa, but it's about 60 miles east of the main island, and we're interested in having a solar and perhaps wind-powered facility there for small translators. So all that's coming up this week in Radio Tech. Our show is brought to you in part by Nautel, and Nautel is also interested in saving you power. And this time we're talking about the AM band. So there's this technology called MDCL, and I forget what that stands for. Chris, if you know, jump right in. But MDCL is this technology where you change the carrier level to accommodate, it's also known as DCC, or dynamic carrier control. It's not a new concept. It's been used for decades under high power medium wave broadcasters around the world, but it works well for AM broadcasters too. And I know there's some other broadcasters in Alaska who have put this to use. Well, at Nautel, they want you to know that they can save you perhaps upwards of $60,000 a year, especially if you're running a 50 kilowatt AM transmission facility. Now, this is all with no increase in distortion, no decrease in coverage. There's a calculator for AM power savings on the Nautel website, and you can go there and see how much money you can save and how much power you can save over time using MDCL. So check that out from Nautel. They're always trying to make a good technology available to you and explain it. That's one thing I really love about Nautel. They've also had some webinars, some Transmission Talk Tuesdays, and some webinars about MDCL. So check that out at nautel.com, and you can go look for MDCL power savings from Nautel. Thanks a lot, Nautel, for sponsoring This Week in Radio Tech. Yeah, Chris?
If I'm not mistaken, MDCL is modulation dependent carrier level.
You're right. That's exactly right. Ding, 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 ding. Thank you. I have the smartest co-host on the planet. It's Chris Tarr. Thank you, Chris. I appreciate it. All right. We're jumping right back in with Becky and Pete. And I'm not sure where you want to go, but I'd kind of like to get some pictures in people's minds about this. But first, Pete, you and I were talking earlier, and Becky too, about increasing power on these translators from typically 10 watts to upwards of about 250 watts. Talk to me about the impetus and the legal reason you might be able to do that, and then of course that's going to involve a 25 times more power, more AC power to deliver that.
Yeah, well, and even a little bit more when you consider the inefficiency of the transmitter.
Oh, yeah.
Well, basically, these are translators that were built in around 1987 or 1988, and they were built on a shoestring. It was a community radio station. They had raised enough money to get themselves started, but they really only had, just a little bit left to like get out to these surrounding communities. Sitka is a town of around 9,000. I don't know how many people were in it then.
Roughly the same.
But there was really no radio service that reached a lot of these towns. There was perhaps one AM station, which I think is still there. But the FM band is essentially empty. And so the founders of KCAW saw the opportunity to provide first radio service to some of these communities, and so they did so. So fast forward to today, Becky, you want to talk about?
Yeah, so the FM translators that were initially granted to KCAW were granted for 10 watts, but over the years, that legal limit had increased to 250, and they just had never been upgraded. Some of these sites hadn't seen a KCAW staff person in ever. So we're mostly just upgrading and updating the paperwork around this for what equipment that we're installing, as well as the power increase, as well as, correcting some of the information, because GPS now and coordinates are far more precise than they were back then. One of the filings, the one that we were talking about for Port Alexander, had the transmission facility in the middle of the ocean. Technically.
Yeah. Well, and plus the 10 watts was enough to do the kind of the modest goal of reaching the people in the town. Yeah. Remember, these towns are from like 30 to 900 in population. And so everyone's within like a mile or so. But over the past 30, 40 years, people have spread out somewhat, along the coastlines. And more than that, there was also the goal of reaching the fishing ships. Talk a little bit more about that.
Yeah, absolutely. So the commercial fishing industry in Southeast Alaska is huge. When there's an opening for a specific fishery, it can be very short, very intense work, and hundreds and hundreds of boats, many thousands of people are working on the water. And not all of them have the benefit of, like marine or like mobile like connectivity like we do with Starlink, with other like BGAN BGAN like connectivity. Yeah. Most people are they're out there, they're trying to do work, and they're not really like glued to a TV set or their phone or anything. And for them to be able to hear like weather reports, like you're going to expect like southeast swell, 20-foot, 6-foot seas, those kind of things are really important to people that are working on the water so they can adjust their plans and location accordingly. And we weren't really serving those folks before. We were, as Pete mentioned, in those communities broadcasting to folks that had a house, but the population of Southeast Alaska swells many magnitudes during the summer. And we wanted to make sure that everybody that was in Southeast, whether or not they were, living here or recreating or working on the water, that they had access to information at all times reliably. And that's what this project is really focused on, is making sure that our public service mission is being met in a really meaningful way.
Well, and I would just say you weren't serving them as well as you should have been, but it's KCAW is really popular among people that work on fishing boats, around here. And so trying to do better for them. One thing you told me, which made me laugh, anytime like an NPR reporter comes, you have a little challenge for them, right?
Yeah. They have to read the marine weather forecast correctly, not making any mistakes under a minute. And
oh my gosh.
Because you're talking about swell, knots, it's like repeated information, and for like, specific areas that are delineated by like south or north or something. And so it's very easy to get it wrong.
Yeah, for seven or like 10 locations or something.
Yeah, 10 locations.
With like
inside,
whether it's
outside
raining,
waters.
height of the waves, it's like it's not easy.
A lot of info in a short time, and a lot of it sounds repetitive, but it every bit of it's important depending on where you are. It reminds me of, I'll refer to American Samoa a few times, as we're wanting to do kind of something similar there in the Manua Islands, and the Samoan forecast, the forecast office there issues the forecast both in English and in Samoan, and there's many more vowels in Samoan. So, hey, Chris Tarr, you've probably had to correct a couple of coordinates here and there on, you take care of a lot of transmitter sites, but none in the ocean, right?
No, not even any in Lake Michigan.
Good deal. Well, we've got Pete Tridish wrote this good article that is fascinating in Radio World, and we've got a couple of pictures from that. So, Suncast, if you want to toss the first picture up from that, it's a equipment map. Pete, what is going on here?
Oh man, well, all right. So, what we start with is that the town has a generator, but it's only on certain times. Sometimes, especially during the summer, only for like maybe an hour every 2 or 3 days. They're just trying to keep they turn it on so that they can get a little internet and check their email, and to give the refrigerators like to keep them from like going to room temperature.
Yeah.
One thing I should mention about the weather around here, it's not exactly what most people think of as Alaska, because most people think of like, dog sleds and snow and all that sort of thing.
Polar bears.
We are in a big archipelago. So we're not connected to the mainland in any way. And most of these towns, if they do have roads, they only go inside the town. They don't connect to any other town.
Right.
So, and the weather, because we're on the ocean, it is not quite as cold, but it is always stormy. I think Sitka is raining more than 60-70% of the year.
Yeah, and our winters are basically a continuous hurricane. So, what people call hurricanes in the lower 48, that's kind of our fall and winter all the time.
Oh my gosh.
Yeah. And so, like, the considerations around it, especially here, you wouldn't think, like, with all that rain, is there a possibility for solar? Can we even sustain a wind, powered thing? And it turns out that everything here is very seasonal, including what available, like, renewable resource there is. And we have to plan all these things around that weather and around the seasons.
Yeah. Okay. So let's go back to that diagram, because we lost that. All right.
Look at that.
So I don't know. There's a lot of boxes here. Basically part of the installation included getting occasional charge from the town generator. And one of the biggest things that we did was we added a 20 kilowatt hour battery bank, 19.2 kilowatt hour. That's enough to run our installation for about 3.5-4 days, sometimes up to 5, depending on like our power profile at the time.
Off grid.
And that's off grid. But we do we're actually kind of doing a little bit of a favor for the town, because when they do have their generator on, it's very powerful and it needs some load. So by drawing off that battery bank, we're giving them some load that they need. Also, another major part of this project was to add some internet connectivity to the sites.
Yeah.
Traditionally or historically, whatever you want to call it, it was a C-band satellite. And so these are, 10, 15-foot dishes that are receiving the satellite that's run by Alaska Public Media.
Yeah,
right?
it's administered through Alaska Public Media. It is a function of the state of Alaska, and the service is called ARCS, or the Alaska Rural Communication System.
Those dishes are all now 40 years old, and many of them look kind of like the lunar surface, all pockmarked and and
may have different
rusting
types of life, or mold, or ferns growing from them.
You need some very, very big wrenches to do anything with them.
Yeah. We needed content distribution redundancy.
Yeah, because those dishes, I would say 70-80% of the times that we have outages, it has something to do with the dishes. Somewhere in that chain. So we really wanted to add internet. We also, the transmitters that were in place, they were old Crowns from vintage 1986, 1987.
Or QEI exciters.
Excellent. Excellent. They were still mostly running, but they were crystal controlled. They looked like something out of Dr. Strangelove, designed to survive a nuclear war. But they just lack a whole lot of the things that you expect from a transmitter today. They didn't have any kind of web interface. They didn't have any kind of processing. They didn't have frequency agility. They were just barely phase lock looped, I guess.
Yeah, and some of them couldn't even take the distribution signal from the satellite and had to be wired differently, or in some cases, a small car transmitter to jump the signal from the satellite receiver to the transmitter.
Yeah. So we wanted to add a lot of internet functionality, which is tough in some of these towns. One thing I'll say about the internet here is the first time I worked in Alaska, I worked in Yakutat, and they told me a story. They had HughesNet. HughesNet has this thing where, if you use more than a certain bandwidth, they start throttling you down to the speed where you can only basically check your email.
Sure.
And one time there was the city hall had a HughesNet satellite, and somehow some teenagers got in, watched about an hour and a half worth of YouTube videos, and City Hall, their internet was shut down for the next week. So
before the next billing period.
And that's mostly what is around. It's starting to transition in the past year with Starlink coming up here, but that's where it still stands with a lot of places.
What I get, Pete, we're going to take a break here in a second. What I get from the diagram that's been on the screen there for a minute is that, well, when you have different sources of power and different systems that you're making work at the same time, and you've got some complication there. You've got UPSs, you've got town power from time to time, certain number of hours. You've got solar and wind and controllers for those. You got some things that maybe it's okay if they shut off. Other things you really want to keep on, no matter what. So there's a lot of considerations there. And what we're going to get back and talk about more of this in just a minute. Chris, Tarr, and I are here with Becky and Pete. We're going to talk about solar and wind-powered radio stations. We got pictures coming up of the actual installations. And Becky and Pete, I'll tell you, this hour is going to fly by. Our show This Week in Radio Tech is brought to you in part by Broadcast Bionics, and we're going to kind of like move into a different world where the power is probably on all the time, and maybe don't care how much you use. We're going to look at the Bionics studio here. We'll be right back.
Welcome to the Bionic Studio. The Bionic Studio brings all audience interaction to the fingertips of a production team in radio, TV, and podcast. Our workflow-led system is working 24/7 around the world for small broadcasters and national and international networks. Our telephony module, Bionic Talk Show, allows cost-effective centralization, remote operation, scalability, and resilience across an entire network of stations, but at the same time is used in single-studio self-op environments. Social media curation and activity is now considered a broadcast-critical part of programming. Bionic Social means the studio isn't overwhelmed with a wall of interaction from an ever-growing number of social platforms. We combine SMS, MMS, and email together with a speech-to-text service for listeners using smart speakers. We enable studio teams to curate, filter, and display all platforms in one place, and post text, images, and video content to multiple platforms in one operation. Effortless collection of video content with Bionic Director has helped position some of the world's most successful stations as leaders in viral content, generating appointments to listen and free marketing via retweets and shares. Bionic Contest enables end-to-end tracking of on-air competitions, live reads, and prizes. These could be on-air contests, automated SMS entry, or online. Anywhere, and Skype TX for Radio brings high-quality audio and video contribution into the studio with ease. No need for dedicated PCs to run different applications. Everything is controlled within the Bionic Studio UI, and incoming connections are visible to users along with all other platforms. Our codec integration enables connection, algorithm configuration, and directory to a wide range of IP and ISDN codecs. The Bionic Studio, a unique suite of products designed to enable your talent to work smarter.
Broadcast Bionics, man, they have a variety of things that'll help your radio station really look and sound great and stream very well too, including the Camera One system, telephone systems using some of them using Telos Alliance phone systems, and also the new virtual rack system. Check them out at bionics.co.uk or bionic.radio. Thanks a lot, Broadcast Bionics, for sponsoring This Week in Radio Tech. Chris Tarr is along here, and so is Becky Meiers and Pete Tridish. We're talking about radio in Sitka, Alaska, that's powered once in a while by the town's power generator, but oftentimes not. And some sites where, well, most sites where, you know, they got to provide their own power or pay dearly for the commercial power that they get. Holy cow, like 95 cents a kilowatt hour. Here in Nashville, I pay 11.7 cents a kilowatt hour. And I know you guys aren't necessarily interested in selling power back to the utility. I am here at my house, you know, when I don't run the air conditioners. It's interesting. I pay them 11.5 cents a kilowatt hour or thereabouts, and they pay me 1.7 cents per kilowatt hour. How do you like that, that difference? They consider me a wholesaler, which kind of tells me how much they're paying for power.
Right. Yep. Well,
So,
it's a funny moment for solar and wind. I mean, you know, when I worked in the industry back in the mid 90s, very, very niche, all off grid. And now it's a much bigger industry. And you know, with the growth, it's all great. It's great that the scale is increasing, but with that scale, you're seeing more scamology. You're seeing more shysters, you know, getting into the space. There's an element to it that's the same as those like crazy dudes that are like trying to sell perpetual motion machines. There's that sort of like free energy from the air, from the sun. You know,
it's magic.
And just like anything. There's nothing free, you know. You either a lot of it has to do with the investment. You know, it's more upfront cost of capital, all that sort of thing. You know, so there's a lot out there that's too good to be true, and you should be suspicious.
Well, if we could, let's move on with our article from Radio World that you penned, Pete. Let's look at the next picture that we have there. Oh, what is going on here?
Oh, now that's a funny one because you notice from this picture, it looks like the solar panels are upside down.
Yeah, you guys know the sun is up there in the sky, right? It's not on the ground.
What do you mean?
This is an interesting new form of solar panel. It's from Canadian Solar. And it actually, instead of having a backing the way that the old ones did, it actually has a second surface. And that tells you just like how much the cost of producing this has gone down. Thanks, in large part to the industrial policy of countries like Germany and China, where they have done a lot to get the manufacture of solar panels to scale. When I was working in it, they were about $5 a watt. And now it's not uncommon to see 50 cents a watt, 25 cents a watt. I've even gotten used panels for 9 cents a watt. So this particular panel, the most of what it gets is from the sun shining on it from the top. But particularly if you have like a white roof, you can get as much as 30 or 40% more sort of bonus energy from the bottom of the panel.
Oh, okay.
Or say if you're in a snowy environment and you have a really reflective ground cover of some sort.
And it was basically the same price as other panels. And that's why I did it. Although in this particular application, the ground is not nearly reflective enough. I doubt we get more than like an additional 2 or 3% out of them.
Yeah.
But it's an interesting new technology, and that's coming up where you get to use both sides of the panel.
I'm curious, would there be any benefit in allocating some space under this and laying out some kind of white melamine sheets, that would reflect from the sides and that be more reflective than grass and dirt?
Well, yeah, we were thinking about it. In this application, Port Alexander doesn't have a deep water port, or it's very difficult to get materials there. But something that might be helpful is if we were able to potentially helicopter in like white fines of gravel or whatever, and then lay that out underneath. I think it would probably increase that. Yeah.
One thing I have to say about that site, when I first walked around it, being from Philadelphia, I'm not too familiar with the climate here. Getting better. This is my third year up here. But when I first walked around the ground, it's just like this. It's basically like a rainforest, right? As I started digging, I discovered that the vast majority of the ground is dead trees, and in some stage of decay. And so it was not easy for us to actually find a spot that we could dig down into to set the concrete and everything, and just like the whole ground floor is very, very unstable.
Yeah.
Wow.
And then with rock, like about 10 feet in, maybe.
Well, about four
or
feet.
5. Yeah.
That's going to play into a conversation we'll have in a few minutes about towers and how you put guy wires in. But I'm sorry, please go ahead. Sorry to interrupt.
No, that's it on that. It's very, a lot of our job involved doing a lot of concrete work up there, which was not easy. But we can go ahead to the towers.
So, and I think you should put a big sign under there and say, hey, polar bears, they're white. Here, lay here, reflect light for us.
That would do it. Yeah.
Yeah, that's another potential revenue stream.
That's
Polar
right.
Bear Hotel.
We're not far south enough for polar bears, but there are a lot of bears.
Speaking of real estate to lay this out on, do you have much land available to put ground-mounted solar panels?
So that's a really good question. In this instance, in Port Alexander, we had the benefit of working with the owner of the grounds, a nearby fishing lodge, and they said basically, like, put whatever you got up here. Nobody really uses it. Again, to paint the picture, it's the top of a 150-foot hill that's mostly like slimy forest, and there's like just a small path that goes to where the shed is and where the downlink for our satellite services.
The first day of work when we got there was rebuilding the path, basically, because it was pretty much impassable. It had been overgrown with thimbleberries and
Devil's Club, and it just had sloughed off of the hill. So we rebuilt that. And then the next few days were, as Pete mentioned, trying to figure out what was going on with the ground and being able to make holes enough in order to put in anchor points that were either decades of blow down or seeping holes of muck or whatever.
Yeah.
Wow. Okay.
And the first year that we worked on the site, which was 2 years ago, it was kind of in imminent danger of collapse. Basically, the old tower, it was a 30-foot roan with one of those 5-foot head caps, and the I don't know if you have a photo of this for that article, but the guy wires were still embedded in the ground, but a tree had grown right through the guy wire. So
Several.
you couldn't find where the guy wire went into the tree, but you could see where the guy wire was coming out of the tree. And the tree was like this big, it was like a 12-inch wide tree.
Yeah.
So
the picture that you just saw on the screen, that was where we were able to improve the tower. So we added how much in terms of tower sections to that?
About 21 feet. We added 3 7-foot sections, and then we moved the top section up again to the top.
And that was in order to clear the tree line, in order to install a wind machine at the very top, and then to put in our 3-bay dipole antenna.
Right, because we wanted to make better use of what power we could generate by getting some gain off the antenna, which we had not had before.
Okay.
It takes some space. It takes, about 20 feet on the tower, which we didn't have at that time.
Can you preview for me a little bit about Becky? You referred to it as a wind machine, and maybe that's the way you call them. But I'm a little curious about can you what you can buy, what's commercially available out there? Just something you throw up and it produces some voltage and current that can feed into a charging system or an inverter system that would also perhaps be fed by solar panels at the same time. Pete, you or Becky, can you kind of just preview that for me? What's available?
Yeah, I looked around. I had not done wind before. I'd done a fair amount of solar before, but I hadn't done wind. And I settled on a company called SuperWind. There's also a great resource, guy, Paul Gipes, who is a pretty good source on wind power. So I looked at a lot of possible windmills, and the first thing I learned about it was that it's really easy to make a windmill that generates power. What's hard to do is to make a windmill that won't fly apart in high winds. Mm-hmm. And the winds around here get up to about 130 miles an hour. And we had heard a number of things from locals about, oh yeah, that guy tried a wind machine. It blew apart 2 years ago. You can see parts of it over there. Mm-hmm. So we went with this one called a SuperWind. Which had a couple of interesting features for safety. One is that as the wind gets faster, it furls and it pushes back. So it keeps on generating power, but it presents less of its face to the wind. And so it tops out at making about 7 3/4 amps at 48 volts. So and the wind here is an interesting resource. It is not that strong at all during the summer, but during the fall and the winter, there's a fair amount of it.
Hurricane season.
We did have the benefit of just having some sort of old wind speed databases that we were able to tap just to get some rough projections. We actually built the whole setup. It's based on the NREL, National Renewables Energy Laboratory data. The amount of wind power plus solar power that we installed would theoretically make about 110% of the power that it consumes over the course of the year. Now, that doesn't necessarily mean that there's always enough wind or enough solar. It makes quite a bit more in the sun during the winter, during the summer, which is when it was most important to us that our power be highest.
Yeah, that's when we see all of the traffic and the increase of population is definitely during the summer. And also, the geography and position of the Earth was advantageous because Alaska has very intensely long summer days. And so we have a lot more resource when it comes to that.
And the
Cool.
fishing industry is not really out on the water as much during
The winter.
the deep winter months.
Gotcha. Hey,
Yeah,
we're
so
talking to Becky Meiers and Pete Tridish. We're talking about wind and solar powered translator sites, and we're going to get into a few more specifics as far as wattage and increasing in wattage and how much they need to generate, whether it's wind or solar. Chris Tarr is along. Chris, are you learning like I am? What do you think?
Oh, absolutely. I mean, my only experience with any kind of wind generation is through the utility. One of the utilities that I have, you can actually purchase power that is offset by wind. So basically what you're doing is whoever, like when you sell your power back, I buy it. So it's still through the commercial power company, but basically the money I'm using is applied towards paying people generating wind power. So that's about all. It makes a lot of sense here. We do a lot of wind generation in Wisconsin. We have wind farms all over the place, just because our topography works really well for that. We have lots of areas that are just very flat that can hold several wind farms. So we do generate a lot of electricity that way. But I really haven't. The issue we have here, I think, more importantly, and you don't necessarily have that in Samoa, but as you know, in the States, we consume a lot of power. So, to try to do that efficiently with solar or wind is pretty difficult.
Got you. Well, hey, we're going to take a quick commercial break and hear from one of our sponsors. When we come back, I've got a little short video that I shot last month, and it just came to mind as we were talking about solar that I want Pete and Becky to look at and kind of drool over. This is a pretty interesting solar installation in Mississippi. Hey, our show is brought to you in part by Broadcasters General Store, and one of their amazing manufacturers that we've all used, and you need to use more of, would be Henry Engineering. Hank Landsberg, he's been a guest on the show before, talking about stuff he designs. And one of the things he's designed for you, for your studios, is the multi-port. I bet Chris has a need for one of these as well. Multi-port gives you all kinds of audio interfaces to your audio console or your audio studio. That's the Henry Engineering audio interface panel. So, hey, people bring in their laptop. They want to hook up some external audio. Hey, here's a song I wrote, or here's some great sound effects and drops that I wrote. I want to record them on the production machine or play them live. Or here's an interview that we did with the coach last night, and you want to just plug it in and play it. The multi-port from Henry Engineering is a great way to interface that into your studio. Also giving you outputs. Let's say a TV crew comes in, high school TV crew, maybe a TV station TV crew comes in and needs to record your station or record right off your console's microphones. Well, how do they plug in and do it safely and not mess you up on the air? Well, of course, the Henry Engineering multi-port is electrically isolated. It gives you amplified isolation between your electronics and whoever is plugging in. That's one of the things that's really important. So the Henry Engineering multi-port is just a terrific way to get this done. And so I would encourage you to look into the multi-port for your operation and check it out. And the best place to get one, of course, is from Broadcasters General Store. BGS has great prices on all of their manufacturers, and I can say that with confidence because they work with manufacturers to get the best pricing that they possibly can through large quantity buys to get either drop shipping or stocking. And also, BGS has gone to great lengths to make sure that they know how quickly things can ship and what your shipping options are. Do you need something overnight? Do you need something? It doesn't matter if it comes until the next week or 2 weeks from now, then BGS can really help you out with that. And I've dealt with BGS many, many times, and even buying Henry Engineering equipment like the multi-port or the Super Relay or the Super Light, any of the Henry Engineering things, BGS is really tuned into to get you what you need quickly at the best price and with confidence as to when it's going to show up. So check them out at bgs.cc or call them at 352-622-7700 at Broadcasters General Store. Thanks a lot, BGS, for sponsoring This Week in Radio Tech. All right, I know I teased this video, and I was driving through real backcountry roads in Mississippi about a month ago. I had to make a quick trip down to Indianola, Mississippi. And on the way there, I thought, wow, that's quite an installation. So on the way back, I made sure I took a few extra minutes to do some video. And so, Suncast, can you roll that video? I gave you a link for it. There we go. Look at this solar installation. Now, those panels do, I guess you call articulate. They move from east in the morning. They track the sun during this is late in the afternoon, so they're pointing west. Now, they're not optimized for winter, summer, but I mean, I guess they're averaged for that. This video is 3.5
I'll just take one row of those.
Yeah, I know. This is a 3.5 minute video of me driving by these things.
Incredible.
Kirk, this reminds me of up in Milwaukee, and we just kind of scratched our heads. Where our tower is, where one of the towers is owned by the technical school, one of the city colleges, and they decided all of that land would be great for solar panels. And the engineers are going, I don't think that's a good idea, but they plowed ahead. And after the first winter, when that tower got done shedding its ice, every one of the panels was cracked. And, we're like, we warned you. I said that it's a horrible place to put solar panels, but they were just plowing ahead. They're like, no, we're going to generate all this power. And as soon as the tower started to shed ice, they almost made. It was almost like solar panel seeking missiles. It was unbelievable.
Wow. Now, you notice there was some room between those rows of solar panels. And some people are thinking, well, if and when Mississippi approves hemp and maybe even marijuana growing, they should just, grow that, between the rows of panels.
Yeah, I could see that practical consideration.
Hey, and the power company sell that, and your power bill comes way down because of the subsidy. Because anyway, all right,
we got to work on the branding for that. That's a winner.
All right, we're talking to Becky and Pete about solar and wind, and we got a video that Pete provided. It's a time lapse. Pete, you want to set this up for us? What are we going to be looking at here? Or actually, we could go ahead and roll it and talk about it.
Well, one of the things that's important, because we only had a 35-foot tower at the time, and the trees on that hill are about 50 feet or so.
Ooh.
One thing that's, and all they had before was they had a single bay antenna. We needed a multi-bay antenna in order to be able to economize on our power usage. And we also needed to get the windmill past the tree line.
Oh yeah, of course.
There it goes.
Because it really needs on. Really, if I had a choice about it, I would add another 20 more feet. But the problem is we're really close to the edge of a ridge, and so to get the guy wires far enough out to support another 20 feet, I don't think it would have worked out.
Yeah.
Also, there's the fact that, Roan, although there are tons of Roan 25 towers all over Alaska, the manufacturer, they don't really approve its use up there because of their concerns about ice. So, I played it, even though it's in a place that's, there's no inspector for hundreds of miles around. I played it pretty cautious in terms of, adding, just as much, tower as the site could provide with proper guying. Probably the wind would be more productive if we got another 10, 15, 20 feet up higher than the tree line. And right now where it is, the windmill is about 4 or 5 feet taller than the closest trees, right around it. So we kind of got the sweet spot of, what's the opposite of a sweet spot? It's like a sour valley, where we got as much height as we could afford, and it still wasn't quite as much as I would have liked, but it's a lot better than it was.
you mentioned this SuperWind company for wind turbines, wind generation turbines, and we'll provide a link in the show notes. So, listeners, you don't have to go there now, but we'll give you a link to it. But they show some sites that are a combination of solar and wind, and I think that's pretty interesting. SuperWind advertises that they're all German engineered. Their stuff won't fly apart in heavy winds. So I think that's pretty interesting. I'm sure there are other manufacturers as well, but we'll provide that link and any others that we come across. I think that's a fascinating thing. It's certainly not appropriate for every place. You need to have wind, at least on a frequent enough basis to where it does make sense. But I guess you can store wind-powered energy in batteries just as well as you can store solar-powered energy, can't you?
There it is.
Yeah, and you can. What always blows me away is you can hook multiple charge controllers up to the battery bank, and they don't really screw with each other. You know, so the wind charge controller is right there next to the solar charge controller, and into the same battery bank.
Oh,
in some ways, like the central thing, the most important thing that we did was really adding the battery bank, because that just like really smooths it out. And, you think about emergencies, you think about all these sorts of situations. Having that battery bank gives you the ability to keep on broadcasting for 3-4 days. And that was the key to it.
Yeah. And lithium ion batteries, like the ones we selected for these projects, they take a lot less in terms of yearly maintenance than what had been used very often around here, which are lead acid marine batteries.
Yeah.
It's still more expensive to buy lithium with your startup costs, but when it comes to the life cycle, most people manage to kill their lead acid batteries within 5 to 7 years, and a lot of times they really take a lot of maintenance. They take water. They take not going too deep. The key with lead acid batteries is even the deep cycle ones, you can never bring them down to less than 50% of their charge. So you're only getting half of what you paid for in terms of storage.
Yeah.
But with lithium ion, you can go down to about 10% of the charge. And they're also not as liable to damage because they don't have water in them. So they can go down to lower temperatures without damaging the batteries.
Do lithium-ion battery packs tend to come with some kind of a built-in charge controller circuitry? Like if they've got multiple cells, you want to keep them all similar. At least in the drone that I fly, the battery's expensive because there's a CPU running stuff in each battery pack. And in my house, I've got lithium battery packs, but each big chunk of battery is not cheap because it's also got electronics associated with it. Is it the same way for yours, or is it just a plain lithium battery that plugs into some larger circuit?
Yeah, it's referred to as a battery management system, or BMS, and each battery has BMS built in. And if there's one weak point to it, the BMS will allow you to drain out power when you go under 0 Celsius or 32 Fahrenheit. But it won't accept charge under that. So for that reason, we had to insulate the shack that we were in and add just a little bit of heat. I set it up on a relay so that whenever the shack temperature goes below 4 degrees Celsius, a little heater kicks on for a couple minutes until it goes back up to 7 degrees Celsius, and then it kicks back off.
Yeah. And just to add to that, one of the things that came with the SuperWind wind turbine was a flex SCADA that we were able to program in order to set the conditions for relays that were monitoring the temperature in the shack in order to initiate the start of like the heater. And there are a number of different relays and switches within this. How is it programmed again? It's programmed through, is it Java or something?
Yeah, it's like a Java interface. Now, that was the scary part for me, because I'm fine with anything with construction, with antennas, with transmitters, and but I don't know anything about JavaScript. So, but the company was very helpful in coming up with JavaScripts that could cut off the. It's interesting the way the wind turbine turns itself off in crazy high winds, like 130 mile an hour or whatever. when you sense more than 7.7 3/4 amps going through it, it throws a relay and it just shorts the two connection wires, and that's the break. We were able to do that with an amp sensor. We also we have one more feature too, which we did. The town has a pretty weak battery bank. And what we were actually able to do was anytime we discovered that our battery bank is over 52.5 volts, it's a 48 volt nominal battery bank.
Sure.
Anytime it's over 52.5 volts, we turn on an AC line that goes down to the town, and plugged into that is a little 10 amp battery charger. And we give the town back a little bit of battery power, a little bit of AC power to charge up their town battery bank. So in some ways, we're extending the length that they can go between, firing up their big generator.
And giving back when they've given so much to this radio station over the years.
So just real quick, tell me about the power budget for a typical site, and you're increasing power on some of your sites. So how much, wattage are you looking at having available 24/7?
Our average load, or our maximum load really, is about 400 watts. That takes into account, 250 watts out of the transmitter, about 25% inefficiency from the transmitter itself. And then the ancillary equipment,
Satellite receiver, the internet, and, and all that stuff. We sometimes reduce that. What we actually bought, no insult to your esteemed sponsor, Nautel, but we bought an Acresso transmitter.
Yeah.
Which is, they have an interesting new feature called Smart FM, where we're not using it yet, but what we hope to do is
when we have authorization,
when we have the authorization, when the technology has been approved in the United States, it can trim down the power output from the RF and save you some power. But what their product claims is that they get equivalent coverage. We fooled around with it a little bit. It's a very interesting potential technology. We weren't able to test their claims in terms of the equivalent coverage because we would need a boat.
Yeah, our own boat to get around.
And just to let listeners know, at least what little bit of reading I've done on this, and it's kind of interesting, Acresso brand transmitters have a couple of different ways they can cut back on power. One is program dependent. And Chris, if you've read differently, if you understand differently, let me know. But if the transmitter believes that the density of the programming is enough, and most listeners wouldn't notice a reduction in power, and they wouldn't notice a noise increase because the density of the program that's going on is so much, that they can reduce power if you want them to. And that's program dependent, maybe a little bit like the AM system that's out there. And the other way to save power, and I've kind of thought about, well, gee, what if we could ask the FCC to do this for my own stations? What about reducing power at 1 o'clock in the morning when the vast majority of our listeners are in bed, asleep, and not listening to the station? Bless their hearts, they ought to be getting some shut-eye. And then, ramp the power back up at 4:30, 5 o'clock in the morning, when our morning show starts back up. Thought about that. Yeah, we could save a little bit of power. What if we could save, 15, 20% power every month? Would that be worthwhile? Well, if we were watching every watt, like if you're generating it yourself and you are watching every watt, that might be important. Chris, have you looked into any of this stuff?
Not really. We're not in a position here where, that would do us a lot of good. When you're dealing with 250 watts or a kilowatt, there's very little savings in doing that, because power here is fairly inexpensive.
Yeah.
It's just like doing MDCL on a 5 kilowatt transmitter. The savings doesn't really outweigh the cost or the effort to put those technologies in.
Yeah. And I'm thinking about, of course, just the translator that we're going to put in the Manua islands, which is going to be solar and perhaps wind powered. Now that I'm intrigued about that. Hey, we're talking to Becky and Pete, and we're almost out of show here. Chris, you've got some message for us about Angry Audio, one of our terrific sponsors, and why don't you take it away with Angry Audio, and I'll be back with Max Connect.
Absolutely. So I got a phone call from a friend of mine who, I've known him for probably 30 years, radio guy, who is now in a different line of work. He works for a wealth management firm, and they do podcasting and a couple of live radio shows on a couple of AM stations in town. And they are building a brand new studio. And they came to me and they said, "Hey, Chris, you want to give us some help with this? We need to get all new equipment." So I sat down and started thinking about this and went, boy, building studios is a really difficult task, especially from scratch, because there's all these separate parts. And then I realized that, with Angry Audio, you can pretty much outfit an entire studio just with Angry Audio products, and it's a whole lot easier to do. So we're looking at setting them up with the Rave console, a couple of the Rebel mic processors, studio tally lights, some of the talk show gizmos, and we're going to outfit most of their studio with Angry Audio products. And why is that? Because they're inexpensive, they're easy to use, and they work. And if you look at all of the different things here on this webpage that they have, there is really something for everyone. USB audio gizmos to get your computers on the air, the mic processors, which, by the way, sound amazing. If you go on YouTube, look for Cornelius Gould's videos on these mic processors and give them a listen. In fact, they're even looking at the C6S software processor for doing some recording projects. So really, Angry Audio is almost a one-stop shop for studio builds. And I'll tell you, it's great not having to strip wires and come up with Franken gadgets to make things work. You see the studio signal lights there. They have the gadget right next to it that you plug the studio lights right into, and it takes tallies from their console or any console and makes the light work. No problem. The audio processors like the C4 or the C level, you plug them in, you make one adjustment, and you go. And it just works. That's one of the great things about Angry Audio is when you're building studios or building facilities, it all just works together. And the build quality is great. And I'll tell you, Catfish, it has the greatest support. I talked to the guy who's building the studio, and he said, "I'd like to get some questions about some of this Angry Audio stuff." So, I said, "Hey, it just so happens that I know Catfish," and I got him connected. And the next day, he's like, "Doc, he's really good. He really knows what he's doing," and gave us some great advice on the studio build. So go to your favorite dealer, look up Angry Audio, and solve all of the studio problems that you have. The problems go away when you get angry. Angry Audio.
One of the things I loved about talking to Catfish, and like you said, he's a designer of the gear. You ask him about any part, any component, any subassembly in a device, in one of his products, and he'll tell you exactly why it is the way it is and why he chose this particular integrated circuit or source this or source that. Just amazing and good, excellent quality stuff. Hey, another thing that you need to know about is from Max Connect Wireless. Actually, this is a product that is actually built under contract by Angry Audio, but it's branded Max Connect. The Max Connect group wanted to give you the option of getting USB audio out of your computer-based FM audio processor with the 192 kilohertz sampled baseband audio, and bring that out to a proper BNC connector to connect to your transmitter. And was born the Max Connect Broadcast U192 MPX USB sound card. Now, people have been using things like Stereo Tool or other PC-based audio processors for FM, and they've had trouble finding sound cards that actually work, that actually give the performance that a professional, that a purpose-built audio processor will give. Well, this solves that problem. The Max Connect Broadcast U192 MPX USB sound card. That's a mouthful, but it is the thing. It is the cat's meow. So you can get, for example, if you want to build up a stereo tool, or the company I work for, Omnia, they make that Omnia SST. It'll work with that. You come out of the USB, out of the computer, and hey, even if you're running this on a server platform like I am, even server platform computers have USB connections on them. And so you can come right out that USB connection into this Max Connect U192 USB interface, and it'll give you that composite output. Plus, you can do analog in and a digital in, analog out, and digital out as well. So if you've got an exciter that will handle that digital output, that AES EBU output, you can hook that up too and have a digital 192 kilohertz output on that. This is an amazing box. The specs are fabulous. I mean, really good. So yeah, check this thing out. You like to build up your own processor or use some off-the-shelf software like Stereo Tool or Omni SST, one of those. This is the cat's meow. This is what you want. Thanks a lot, Max Connect Group. Check them out at Max Connect. I know it's spelled funny because it's the internet. MAXXKONNECT.com. All right, we got a couple minutes left here, and I did warn our guests. We're going to ask you for a tip of the week. So, Becky and Pete, you're on for giving us a tip of the week about solar, wind, or whatever you like.
Oh, golly. Okay. So just a little background. I was in management and I have now moved into operations and engineering. And my tip was expect that most of your job is probably going to be landscaping.
Okay.
Like don't be afraid of your shears or your what is it, chainsaw or whatever. Like that has been such a crucial part of this work that I expect it to be a part of everything. I'm sure like trying to dig your way into a transmitter facility and some long forgotten infinitude of isolation mountaintop will be your friend. Bring the shears or a machete.
More machete. Oh my goodness. Pete, do you have anything to add to that before we go?
Well, I actually recommended it before, but I'd say if you're thinking about getting into wind, Paul Gipes has written several books and he has a great website. It has some great stuff about some of, like anything, the bigger something becomes, all of a sudden, like you sort of get more shysters in it. Mm-hmm. And so to be able to tell the difference between the things that really work and the things that are like sort of virtue signaling architectural decorations that you put on top of buildings to make them look eco-friendly, I would really take a look at some of his work so that you can like sort of figure out like where the real energy benefits are in wind.
And you're not.
Pete, if you wouldn't mind, send me a link or two to Paul's work, and I'll put that in our show notes. If you wouldn't mind, would you do that for me?
Sure thing.
Okay. All righty. Hey, and you two don't go away after the show. We're going to take a picture of you for our promotional. We got to run. Thanks so much to Suncast for producing today's show, doing a bang up job as usual. Thanks to Chris Tarr for being here. He had to zoom right out of here, so he can't say goodbye. And thanks also to Becky and Pete for being our guests, talking about wind and solar powered translator sites for FM radio. It's been a really fun show. I've really enjoyed this. We got to run. Thanks a lot, and we'll see you next week on This Week in Radio Tech. Bye-bye.